Now the difference between the two is that here our lapping is going to be this way. After our wood this way, then our lapping will now be additional joints, pattern that will be used to pattern it. But in the first one, both will lap this way. So that is why you have the difference of half length of wood. So, but we are using this. We are considering this. We are not using this. So, whatever that is being designed for, or whatever yes, you have to determine your decide on what you want to use among the two. So, if we need to determine what we are going for between this and that. Go for the next one. So, in order for us not to, because with this we still achieve the required strength. So I wouldn't want us to go for the external pattern, so that it won't, because by the time we add half now, it will be 1 by both sides times 21. That's 21 more length. So that might even be when you consider that when another carpenter, for instance, gives you the quote of that is lesser than 21, while the other one is higher by 21. You thinking this one you want to waste in material, like without knowing the plan of both of them. So for this purpose, at the same time, you can actually use this so that when you want to bid for the project, there are some clients that they will still cut it and tell you to project, I will not buy more than this. I will not buy more than this. So, but for the purpose of this calculation, let us consider this. Oh, okay. Let's go for this. Let's go for the second one. Okay. So we are using this. Let's say we are using this. So the number of Rafter now required means 3.5 is what is needed for only this. We have 1 length, 2 length, 3.5. So and this side and there another 3.5. So that will be 7 times the number of kinkos that we have. But now it will be the number of kinkos per se, because we are going to the cables won't get to this place. It won't get to this place. Now let's now determine. But now we know that we need 7 length for each side. We need 7 length for each side. 7 length. I think we still have to do more of calculation now. This and this will be 7. So now we need to determine this. Where will our kinkos start from and where is it ending? Then, basically it has to end on ideally or preferably it has to end on any of the tie beam. It's better for it to end on any of the tie beam. On some rare occasion, you can decide to position another thing here to work it out and make it to end at the center. But now you have the option of either using 2.4, that if it ends here, this is the beginning of the tie beam, and there won't be any kinkos there. As a fact, this won't be here. So this, the tie beam is spaced 1.2 at 1.2 interval. So this is 1.2, this is another 1.2. So which means if it is ending here, it means this is this space is 1.2. And if you choose to make it to start from here, that is our slope, this ridge as well, we also start from this place. It means from here to here will be 3.6. So what I'm saying in essence is this so is this. So where this point. So we have the option of either going for 1.2.4 or 3.6. 2.4, it means we will leave one title, the first title will be there, this one, and start inch our rafter here. Start our rafter from here. This is 2.4. With 3.6, it will be here. So let us consider 3.6 in this case. 3.6. So it means if it's going to be 3.6, that means you start from somewhere around here. Unless we rearrange this, then that will mean 1, 2, 3. There won't be 3, 1, 2, 3 king posts. But it starts from the fourth tie beam. It will start from the fourth tie beam. They even made a mistake. During the king post we did, we said we got 21. So we didn't consider this. We should have considered this. The king post will not start from the tie beam. It will not start from the first tie beam. It will actually start from either the third or fourth, depending on your design. It's either to start from either this third or the fourth. So which means if we started from this, we are considering 3.6. If we started from here, it means 1, 2, 3 will not be there. At the back as well, 1, 2, 3 will not be there. So that means the figure we got -6. So our kick post should be 23 minus 6. 23 minus 6. So what would that give us? 23 minus 6. 17. 17 times this will be what?
17 times 1,650.
Yes.
28,015.
So now you are good to go now. This is 17. Is this 17 that we'll now use now? It means our king post there will be 17. And likewise, the rafter too will be on the king post. So our rafter will now be 17 times 6. Do not forget times 7. This 3.5 times 2 for both sides. 3.5 is for one side, the other 3.5 for the other side. So what would this give us? What would this give us?
17 times 7. Yes. 119. 119.
119 length. Now we are not done. We are not through. We have only done this, these ones, all these ones, all these ones. We are left with these diagonal ones, and this one that will come this way. You know, we are going to have this way as well. Okay, let me use marker there. After will come this way. This way. So now let's move to these diagonal ones. Still going to add it to this one. Do not forget, you need to get this diagonal one. Ready? Now we want to get it at the upper level, not at the ground, not at the plane level. Do not forget, this is what we have there. In some cases, the shape of the building is not regular. We are trying to also construct our tie beam in this shape. Our tie beam can be constructed in this shape, so that the upper one, the rafter, when the king post is there, the rafter will now come this way. But because the shape of this building is regular, so if we decide to make it this way, these two tie beam will not have something to rest on. So but now what we want to determine now is the diagonal this way. The diagonal, we want to determine the diagonal as the hips, or call it the ridge, rather, this and this. First, before we now move to these small ones, these small ones, this as well. The one we have done is just from the beginning of the rafter to the end of the rafter. So now we want to get this and this. So we have two ways. Yes, we know this dimension, we know this as well. So yes, we can now find this. After that, we'll now position our thing in this. Now at this junction, I need to sketch the 3D of what I'm trying to explain. So as we have something like this, this way. Our typing, okay, typing. This is a key post. Key post should be this way, this angle. Okay, now making any sense? At the bottom here, there will be another one here. There will be a triangle in this form. This is a triangle on its own. A right angle triangle precisely, while this will be an isosceles triangle. Let me make it more detailed. So this is the triangle, this is rafter, the ridge rafter. And of course, I'm still going to have another one this way. Likewise, the tie beam in that direction. Okay, we don't only have the tie beam in that direction. It's not a must. Now, so before we can determine this length, the length of this, we need to determine this from here to here. We need to determine it. So we know this. So that will now give us, that will be two unknown. This for now, we have the king post. We know the height of the king post. we don't know this hypotenuse, we don't know this the adjacent one. We don't know it, so we need to determine this so as to give us what this length will be. So and that will be, how do we determine that? It is for us to get it through here, through this first. To get it through this first, we know this place, this point to this point, which is the span, which is 12. So they run, half of which will be 6. So here will be 6. Here is 6. Here is 6 meters. And from here to here, we know it is 3.6 because we are using 3.6. 3.6, okay? 3.6. So we can determine this now. After getting this, we now use these two to get this. So let's bring that out. Ideally, what we are supposed to have there is this. Going to be this way. And here is 6 and here is 3.6. We are looking for here. So how do we get that? This is hypotenuse. So hypotenuse square equals opposite square as 3.6 square plus adjacent square. That will be square root of 3.6 square is what? 3.6 square.
12.96.
12.96 plus 36.
48.96.
Root 48.96.
6.99. 7.
7 meters. So it means from here to here will be 7 meters. Now, good now, and we know our king post to be 3 meters. So this is 3. So can I use that to determine this? So can I also bring back our triangle. So this is a 7. This is the king post 3. Okay. Let me make it more realistic. This is 7. I'm looking for here. Say R. So still using same thing. So our R equals square root of 3 square plus 7 square, which will be 3 square is what, 9 plus 7 times 7 49. So square root of 58 is what? Square root of 58.
Square root of 58.
Yes.
7.615.
6 meters. So it means this will be 7.6 meters. This will be 7.6 meters. That will be 7.6 meters. we good to go? So, and we have 4 of it. We have 4 of it. So what I'm saying is this. So 1, 2, 3, 4. So before we move on, 7.6. Let's now determine the 7.6 plus 0.6. That will give us 8.2. Now the 8.2 divided by 2.9 will give us what?
2.8.
8.2 divided by 2.9. That's
2.8.
2.8. That's 3 numbers of wood. So we need 3 numbers to get this. And we have it in 4. So 3 times 4 corners or angles will be 12 numbers. Let's add it. Okay, that's our second one. Okay, we can still leave it. So we are done with these ones up to this angle, up to this angle, up to here. You are done with this and this. You are still left with this triangle, and this right angle triangle in 4 places. 1, 2, 3, 4. So we have 2 figures now. As far as our rafter is concerned. Now, can I move to this place? So we need this place, the length of this middle one. Or before that, I will complete these. Yes, let's complete these angles. These angles from here to here in 4 places. Yes. Likewise, here. Let's complete that. Don't forget just 3.6. So we want to add 3.6, and that means at 2.4. That's 1.2 from here, 2.4 from here. Another 2.4. There will be 1 here, another 1 here. Clear? So this is 0.6, this is 1.1 with 1.2. So we need the rafter and another one here. So we need the length of this, place and the length of this place. So what's our length here?
6 meters.
No, I mean the rafter. So 7 point something or so. Okay, yes, 7.3. 7.3. So we now have to use 3.5 lengths of wood. From here now, I'm going to use 3.5 lengths of wood. Here, I don't want us to waste our time here, so we can just proportion it. So this is 3.5. So can do it this way. This 3.5, this is 0. So half of which will be 3.5 divided by 2. That was this. So if it's going to be at the middle, it will be about 2 here, about 2 lengths. So now it's closer than 2, is a bit okay, yes, it's moving to this side. So you can say the 3, we have 2 here, yeah. So this space can be about 2.5, 2.5. While here will be 1.5 or 1. So you can go it this way, 2.5. Then this 1.5. Yes, 2.5, 1.5. So one corner, that angle alone is 4. Numbers of wood times 1, 2, 3, 4. So times 4, that is what 16 numbers. So we are done with all this equation. This only left with this and this. So after that, by the time we get this now, we multiply it by 2. We now add it up with this, and this. So now, okay, this place now. Very good. We need to get this, the middle point first. This 119, let's write somewhere. Okay, let's put it here. 119. Next figure was 12. The next one was 16, so that you can work that up. Before that, now we want to get this place. Do not forget that it is not the flat triangle that I want to get. And the triangle this way, the other king posted now come this way. Now I'm forming. Oh, let me use red marker there. This way, forming this. This is the flat one, the flat bottom, the flat. So we know this space as well, 3.6. This first, the black, the one in black, the triangle in black is what is there? Is the plain one, the plain surface of the plan of the roof. Though there is no member here, there's no member here at the lower part, but there is at the upper part, and there's another one that will come this way now. There's a member that will come this way and this way. So we know this, and this as well is 3.0. So we want this now, we need this. So still using, let's call this our new R now. So R square equals 3 squared plus 3.6 square. Now we will root 9 plus 3.6 square is what?
12.96.
9 plus 12.96. Okay, is it the same with okay,
that's 21.96.
21.96. Square root of it was what?
4.6868
plus.
It's 4 point. Can say 4.69 because actually is
9. So this projection now, the each projection 0.6. That will give us what? That was 0.6.
10.69.
That will be 10.7 meters. Now 10.7 is just this middle one. So we still need to count this way and count the number that we needed here. So which you can see proportion as well. Oh, let's do that now. We have this is 6 meters, and it has now been projected. The each projection has been added, making it to be 13 point. Okay, we don't even need to consider that. Still our 12. Still our 12. This is 6. This is one we have got. So This is center one. You need 1.2, 1.2, 1.2. So how many 1.2 are we going to have here now? For us to get our 1.2 plus 1.2, that's 2.4. Plus 1.2,
3.6
plus 1.2,
4.8
plus 1.2, 6 meters. 6 meters. So it means 1, 2, okay, 1, 2, 3,
I have like 5.
5. 1, 2, 3. 1, 2, 3, 4, 5. So it means it's going to be 5. 5. But the only thing is that there is a member that will come this way. So this one will go this way, this way, this way, and this way. So now we have got this. We want to determine 1, 2, 3, 4. This is the edge. We don't have anything there. We want to determine 1, 2, 3, 4. This length why do you get 10.7? No, 4.67 plus 0.6. That's 4.7 plus
Should we make it 4.7?
it's the same as 4.7 plus 0.6, that's 5.3. Where do you get 10.7?
Wow.
That's what?